This is a video from section 7.2. The directions say to evaluate the integral. Example 1 says the integral of sine 8x times cosine 5x dx. And so this is going to require a special formula called product to sum formula. And so we're going to take sine of A times cosine of B. That's going to be 1/2 the quantity sine of A minus B plus sine of A plus B. So I'm going to use that for the integral above. So I'm going to take sine of 8x cosine 5x dx. So I'm going to pull a 1/2 out in front of the integral, and then I'm going to integrate. Now, 8x minus 5x is 3x, and 3x is the argument for the first term. So I'm going to get sine of 3x. 8x plus 5x is 13x, and that's the argument for the second term. So I'm going to take sine of 3x, and I'm going to add sine of 13x dx. And so here I'm going to take 1/2 of the integral of sine 3x dx is negative 1/3 cosine 3x. The integral of sine 13x dx is minus 1/13 cosine of 13x. And then I'm just going to add my constant of integration. And so when I distribute that 1/2 in, I get negative 1/6 cosine 3x minus 1/26 cosine of 13x plus c. And that's how you do example 1. Example 2. Suppose I give you the integral of t cosine to the 5th of t squared dt. Now, we're going to simplify this a little bit by a u substitution. So I'm going to let u be t squared. Du is 2t dt. And so t dt, if I divide both sides by 2, is 1/2 du. And so right away, this is going to be 1/2 the integral of cosine to the 5th u du. And so when I see an odd power like that, what that leads me to believe is I need to pick off a cosine. So I'm going to write this as the integral of cosine of u, and then I'm going to multiply by cosine to the 4th u du. And so I want to show you something slick here. So I'm going to write this as 1/2 the integral of cosine of u, and then I'm going to multiply by cosine squared. Let's write that again. So that's going to be the integral of cosine of u times cosine squared u to the 2nd power du. And so the whole idea here is I want to write cosine to the 4th of u in terms of the sign. And so if you notice, this is going to be 1/2 the integral of cosine of u times 1 minus sine squared u to the 2nd power du. Now, interestingly, this is going to require another substitution. So I'm going to let v be sine of u. dv is cosine of u du. And so the 1/2 hasn't gone anywhere. That's still there. But we're integrating 1 minus v squared to the 2nd power dv. Now, this is one of those situations you have to square out 1 minus v squared. There's no choice. And so here, this is 1/2 the integral of 1 minus 2v squared plus v to the 4th dv. And that becomes pretty straightforward. And so this is 1/2 of v minus 2/3 v cubed plus 1/5 v to the 5th plus c. But remember, v is sine of u. So I would do this a little bit at a time. So if you don't mind, I'm going to distribute the half in. So I'm going to get 1/2 sine of u minus 1/3 sine cubed u plus 1/10 sine to the 5th u plus c. Okay? But remember, got to go back, u is equal to t squared. You have to have everything in terms of t. And so this is 1/2 sine of t squared minus 1/3 sine cubed of t squared plus 1/10 sine to the 5th of t squared plus c. And that right there is how you do example 2. Let's take a look at example 3. Suppose I give you the integral of secant squared y times cosine cubed of tangent y dy. And so right away, I know that the derivative of tangent y is secant squared y. And so I'm going to simplify this by letting u be tangent y. du is secant squared y dy. And so this gives me the integral of cosine cubed u du. But when I see an odd power, I want to pick off a cosine. And so I have cosine of u, but I'm going to multiply by cosine squared u, du. Okay? But I could write that cosine squared u in terms of sine. So this is cosine of u times 1 minus sine squared u du. Now, if we're comfortable, we can integrate from here. But it takes time. So let's write this over on the other side. So we got cosine of u times 1 minus sine squared u du. And so I'm going to let v be sine of u. dv is cosine u du. So it's a substitution. And so this is the integral of 1 minus v squared dv. And so this is v minus 1/3 v cubed plus c. But v is sine of u. So you get sine of u minus 1/3 sine cubed u plus c. But remember, u is tangent y. So everything has to be back in terms of y's. So we get sine of tangent y minus 1/3 sine cubed of tangent y plus c. And that's how you do example 3. Example 4. I want to talk about this one. Suppose I give you the integral of 1 over secant x plus 1 dx. So I don't know what to do with that, but we can rewrite that integrand. And the way to do that is in the numerator, I'm going to have secant x minus 1. In the denominator, I'm going to have secant x plus 1 times secant x minus 1. So in other words, what I did was multiply the numerator and denominator by the conjugate of the denominator. Okay, that's called the conjugate. So I could multiply by 1 and change nothing. Now, the denominator is secant squared x minus 1. The numerator is secant x minus 1. And we're integrating with respect to x. But remember that secant squared x minus 1 is tangent squared x. So over here, I'm going to have secant x minus 1 over tangent squared x dx. Right? So now, let's split apart this fraction. So we're going to get secant x over tangent squared x minus 1 over tangent squared x dx. So we have this. Now, I'm going to write this in terms of sines and cosines. So secant x is 1 over cosine x. And then I'm going to divide by sine squared x over cosine squared x. And then I'm going to subtract, well, here I can call this cotangent squared x. And this whole thing is being integrated with respect to x. I'll explain what I'm going to do with that in a minute. Now, I could rewrite the first term. And so this is going to be the following. This is going to be the integral of cosine x over sine squared x. And then I'm going to subtract cotangent squared x dx. Now, recall. One plus cotangent squared x is cosecant squared x. So cotangent squared x is cosecant squared x minus 1. And so this is the integral of cosine x divided by sine squared x. And then I'm going to subtract, in parentheses, cosecant squared x minus 1. And this is dx. So that's what came to my mind. There could be other ways, okay? And now, over here, this is equal to the following. Now, this here is going to be, if we integrate the first term, I think of that as like a 1 over u squared. So the integral of 1 over u squared, du, is negative 1 over u plus c, where u is equal to sine x. So this is negative 1 over sine x. Okay? And then the integral of negative cosecant squared x is positive cotangent x. And then I'm going to add x, right? Because a negative times a negative is a positive. And the integral of 1 dx is just x. And then I'm going to add c. And so this is negative cosecant x plus cotangent x plus x plus c. And that's how you do example 4. Let's take a look at one more for this video. Example 5. This one's pretty good. If we have the integral from 0 to pi over 4 of square root of 1 minus cosine 4x dx. So this is a really good question. Now, recall. If I take sine squared x, we get 1/2 of 1 minus cosine 2x. So I'm going to replace x with 2x. Or maybe if it helps, replace x with like a 2a or something. And so sine squared of 2a is 1/2 of 1 minus cosine of 4a. And then I'm going to solve for 1 minus cosine 4a. So 1 minus cosine 4a is 2 sine squared of 2a. Now, so this is nice, because now watch what I'm going to do. I'm going to take the integral from 0 to pi over 4 of square root of 1 minus cosine 4x dx. And I'm going to write this as the integral from 0 to pi over 4 of the square root of 2 sine squared of 2x dx. Now, we need to think about something here. X is between pi over 4 and, well, it's between 0 and pi over 4. And so I'm going to multiply through by 2, and I'm going to say 0 is less than or equal to 2x, which is less than or equal to pi over 4. And so you notice how the lower limit is 0 and the upper limit is pi over 4? So this radicand will never be negative. Why is that important? Because when I go to the next line, I'm going to take out a square root of 2, and I could just write this as sine 2x. I don't have to worry about putting absolute value bars around sine 2x, because 2x is between 0 and pi over 2. That should be a 2. And I don't have to worry about sine ever being negative in the first quadrant. Okay? Now, this is square root of 2 times negative 1/2 cosine 2x from 0 up to pi over 4. So this is going to be square root of 2 times. When I plug in pi over 4, I get cosine of pi over 2, which is 0. And when I plug in 0, I get cosine of 0, which is 1. And then 1 times negative 1/2 is negative 1/2. So you end up getting square root of 2 times 1/2. And so the answer here is square root of 2 over 2. And that'll conclude this video for section 7.2. And we did 5 examples evaluating the integral. And this is in trigonometric integrals. So, okay, thank you.